Okay, so this is a lecture recorded for March 23rd, 2020. Although today is not a March 23rd. So as we have been instructed to move all courses online, so I'm going to record all videos for the rest of the semester. Now this video is a continuation of the double integration that I mentioned before the spring break. Now before spring break, I also post a video to explain how do I compute the double integration by rewriting the standard double integration with the form, typically with the form integration over S the region area. This is a 2D area in a 2D space of a function f(x, y) defined over this area and dx dy, and this one can be written as a double integration of the same f(x, y) over dx dy. Now we're trying to figure out the lower bound and upper bound for this is the lower bound for integration, this is the upper bound for integration. So essentially we have two steps. The first step is trying to figure out the inner integration, then the second step is trying to figure out the external integration. So that's the steps we want to follow. Now the key question is, how do I find the lower bound, upper bound, and lower bound over here? So as a recap of the video, okay, if you haven't watched the video, I strongly encourage you to watch the video to get an idea about what is the main idea we find the lower bound, upper bound. Okay, as a recap, the main idea for to find the lower bound, upper bound here is we first started with you can start with either inner integration, outer integration. For the integration, so this one typically is a function of whatever variables outside. So if this one you start talking about x, so the lower bound and upper bound typically is a function of y. Of course it can be just a constant number independent of y, but it may be a function of y. But outside is just given by this one should be a value. For example, is a y and a bar and a y bar. Let's see, it's a give a and b. Okay, a and b over here. Those a and b are actual values. They're not a function of anything. So essentially, you first compute the inner integration and then you compute outer integration, which will give you a scalar or a number. Okay. To give you some more ideas about how we compute it, how to figure out the lower bound, upper bound. So I'm gonna give you an example over here, and also go over some general examples later on. So that hopefully can help you understand how you find the lower bound, upper bound for the inner integration and external integration. So let's get started from the first example here. So the first example says I'm going to talk about integration of 2, okay, this is my 2, over area of given by this shaded area over here. This is the area of S I'm going to integrate over. So I want to rewrite this one integration. Basically I have this problem. How do I figure out? So I have this, let's see, f(x,y) is 2. So I want to figure out the integration of S f(x,y) dx dy. So according to what I said, the main problem is trying to figure out to divide it into 2 steps. This inside one is called inner integral. This outside one is called external integral. So okay, now according to this video, what I mentioned over here, the basic idea for you to figure out the upper bound is the outside, this outside one. Okay, for the outside one, this is the inner one, and this is the outside one. Okay, for the outside one, just figure out the region for the area, what's minimum y you have, and what's the maximum y you can select. Okay, if I talk about this region is given by a triangle area, and starting from the x-axis for x starting from 0 to 4, and then the triangle, this one, the upper bound for this y for the x is given by a line. This line over here is determined by y equal to x over here, and this one is perpendicular. This line is right hand side is given by perpendicular line at x equal to 4. So you get this triangle area. So for the outside one, what you have to do is try to figure out what is the if I want my y to move so that I can cover the region. So what's the minimum of y you can select? So the minimum basically is 0, because if it's below 0, which means if I go to the left hand side, if you below 0, y is below 0, you're right here. We're talking about somewhere over here. So nothing, because this area S does not fall under this area. This will not belong to this shaded area. So you must start from 0, and then maximum you can pick is 4 for y, because if you go beyond 4 over here, not defined, it doesn't belong to this area. So y starting from 0 to 4, as we can see. So basically this one says is the minimum of y in this S. Now this guy is maximum of y in this S region. So that's what we figure out. So 1, 0, 1, 4. Okay. Now for inside one, we try to do what it says is for every y, you want to integrate from here. So what it means, I want to integrate for every y. If you select a y over here, I want to find a straight line that is when y is this number. So let's say this is y is 1. You just pick this 1 and let it to be constant, right? So because y is 1, you straight line perpendicular to the y-axis. This is 1, for example. You try to figure out, okay, if you do that one for this region, because I want to talk about this region. So what is the smallest number when this line intersect this region? Okay, when it intersects, it gives this one, this portion. So you find the minimum and the maximum. The minimum will be somewhere over here, the minimum, and the maximum will be just upper bound, basically. Okay. So, but be careful, because this one for different y, the lower bound and upper bound may be different. Okay. For example, if y start from 0, your line is here. So you start from 0, your x will start from 0 and to 4, right? But if my y start from here, okay, from 1, for example, if you do over here, because this line is y to x, you project onto x, your x will start from 1 until, of course, until 4. So as y changes, y start from a different number. When it draw a line, when y is a constant, this constant number cross this area, intersect this area, you got a different starting and ending point. Those will determine the lower bound. This is the lower bound for your inner integration, for inner integral, and this upper bound, this will be the upper bound for also inner integral. So essentially for different y's, the lower bound, upper bound can be changing. So for example, here the lower bound actually changes, because as y increase, your lower bound also increase linearly with respect to your y. That's why here I have y as a lower bound, because as my y increases, my lower bound for my x, because it's always talking about this portion. When you let y to be constant and you draw a line across this area, trying to figure what's lower bound, upper bound for x, you sort of project here over here. You get here starting the lower bound for x, this will be the upper bound for x. Okay, so this lower bound will be y and upper bound will be always 4. Okay, so similarly, of course, this is you can also change the sequence. You don't necessarily have to start to integrate the y as external and as internal integral, and you can switch the order. When you switch the order, you basically have integrate y first, integrate x later. Okay, so according to what I said before, you still have inner integration and you still have external integration. Okay, but the numbers will be different. Okay, first look at the d as for the x. According to what I said before, your x for the outside, you want to say for this region, we talk about the same area over here. So what is the maximum or minimum for this x? It will determine the lower bound, upper bound, right? So the smallest one you can select for this region for x is 0, right? If you go smaller than that, it doesn't it's not included the area. So your minimum is still 0. For this area, your maximum is still 4, because beyond 4 is nothing. It's not including this area. So it's still 4. And here for y, this one's a little bit different because I want to check for every x. You make x to be constant and integrate over this one, right? If I make x to be constant over here, so you do this way. If x is constant, it's perpendicular to x-axis is this line, this straight line, okay? So when you use this straight line, you cut across this area, intersect this area, you got this line. For different x, you have different line, basically. You do over here. So, but anyway, for any line, for any x, you always start, well, any line you get over here is always start from 0, right? And end at x, because the upper bound is determined by this y equal to x. So the upper bound is given by x. So for different x, if you start from 0, you can tell you start from 0 to 0, because you just have 1 point. If you had a 4, x is 4, for example, you integrate from 0 to 4. That's why for different x, you integrate it differently, okay? So I hope this gives idea about how we figure out lower bound, upper bound for this simple example. Okay, now let's go back to this a little bit more complicated example. So let's say for a region S, which is given by a circle. Okay, it's a little bit more complicated. So this circle is given by centered at origin, and the radius 1. So this has been -1. Okay, -1. Okay, so I want to integrate let's say just 1 of dx dy. So you can have any function fxy. It doesn't have to be 1. This is your example of 1 fxy is equal to 1. So again, the key question becomes, how do I figure lower bound, upper bound for both the inner integral, this is my inner integral, and this is my external integral. Okay. So let's again start with the external integrals. The internal integral for y is always trying to figure what's the minimum of y and what's the maximum y I can select. Okay. So for the circle is centered at origin, it's fairly easy to see because the maximum is 1, right? This is maximum is 1. You can look at 1. Beyond 1 is does not belong to region. You can also smaller than -1. Okay, so this is a -1 and a +1. So this is always, I can mention the maximum and first second of y in this region S. This is a minimum. This one has to be maximum of y in my S. So this guy is what? This guy is for any y, means constant. What is the lower bound of x1 given z y? Okay, for example, if I give a certain y, let's take a look at what this means. This one means a lower bound when I given y. If I give you a certain y, let's say my y is here. Okay, now I want to figure out, so this is want to draw. This has to be constant because this is a constant y. So constant y means is this. So any point on this line should be y. Should be always be y, right? This is always y. Say this is 1/2 is always 1/2. Then I want to find when this line, when this one define a line has to be in this area. Of course, cannot be outside. Otherwise, you don't include over S. Then I want to find out what is the lower bound. So this one basically is this lower bound. Let's say this is let's call this a C. So this will be just C. So when you do that, it will be C. Accordingly, this guy will be just a D. Over here is for any y has to be constant. So what is the upper bound of x1 given that y? Which means, hey, if I let this y to be some value, and I typically will draw a line. When this is you get a line because you can have different x. When you draw a line, you find the line, when the line within this region area, what is the maximum you can find for x? Okay, this will be just D basically. Okay. Now how do we figure out what is the C and the D value over here? Okay, because it's a circle, I can draw a line from this point C to, because C has to be on the circle, on the boundary. If it's not on the boundary, it's not smallest. You can say it's here, but it is not smallest. If you see prime here, it's not smallest, because you have to find the smallest. It's lower bound, right? So when lower bound should be on the boundary. So when the boundary, I draw a line from here to the origin. So I got a straight line. So the straight line here says this is 1 because the radius is 1, so this is also 1. And also I know here this is a y because I already tell this is a specific y you selected, right? And this is a perpendicular, right? It has to be 90 degrees, right? So I can figure out this length. This length is given by the absolute value of c is the length of c has to be given by square root of 1 minus 1 squared minus y squared. Use triangle relationship, which is square root of 1 minus y squared. Okay, because c is negative, because apparently it's to the left hand side, so c is negative square root of 1 minus y squared. Okay, so similarly I can compute the d, because d I can draw a line from the origin to d. Okay, this line, straight line, has a length of 1, apparently because it's a circle with a radius 1. Now this is d, again d also given by 1 squared minus y squared. Okay, according to the triangle relationship, the square root of 1 minus y squared. Okay, the differently is this d has to be positive according to what is here over here, 1 minus y squared. Okay, here's what we have. So that's why this lower bound will be just negative square root of 1 minus y squared. This will be square root of 1 minus y squared. Okay. Okay, now let's go to a general case. When we have a general area, how can we do that? Okay, so assuming that this is my general area, I want to integrate it over. Okay. So let's say my question is this is the area region given as S. So when I integrate over S, I actually can't have any function dx dy over this region. So which again is trying to figure out what is the lower bound and upper bound for my inner integration and external integration. Okay, I still have to figure out these 4 numbers basically over here. So the integration is given by this, and external integration is given by, let's draw it again using the same color. So inner integration, and this is external integration. Okay, so for the external integration is always trying to figure out the smallest number you can find for that particular variable over here. This is for y. What is small number you can find for the region, right? So according to y, the smallest number I can find out is apparently it's c, right? Because this is the smallest one you can find. This d is the maximum you can find. Okay, so this one I say is c and d. So it's pretty straightforward, c and d. Just smallest number you can find for y for that given region S. Now this one is given by, again, the same meaning that I mentioned before, is you let y to be constant. This is again, you let y to be constant, which means you draw a line. Because when y is constant, it's a line like this. Let's say this is y, you draw a line somehow like this. This is your line you can draw. Of course, you don't consider this one outside is region S, because it doesn't make sense. We don't integrate over there. So you only talk about this y when it is well defined, which means within the region, within this region S. You find this is the smallest, and this is this lower bound, upper bound. So this will be lower bound. What? Because for different y, you could change it differently, right? You could change it differently. For different y, to change differently. So the lower bound change upper bound is not constant. It depending on what y you have. Assuming here, let's assuming here, this lower bound is a function of some y. Let's say, for example, this is my given by piece of y. Okay, so the upper bound, let's say, is given by upper bound on the right hand, upper bound on the right hand side is given by, this side is given by, let's say, q's of y. Now you can sort of say this is a piece of y, q's of y. Okay, so this is how we can do it. Of course, you can also do the opposite way, switch out of x and y. Do here is dy dx. I keep fxy over here. Okay. Now you could have, this is my inner integration and my external integration. So again, I still have to figure out the 4 numbers. which are the lower bound, upper bound for the inner integration, and the lower bound, upper bound for the external integration. So for here, for x, for the external one, because this variable is y, so x over here, so I figured out what is the lower smallest number that I can find for x. One for this region, what is small number of x I can select? Okay, apparently here is a and b. A is the smallest, so b is the largest. So here is a and b. Okay, and now here's lower bound, upper bound. Okay, this is when you given a constant x constant. You want to figure out what is the y, what the y should be. Okay, if I do a similar way, so let's say this is my x, I'm given some x value. Okay, you want, because constant x means you're gonna have go up, straight up. Let's give you the same x value. You're gonna cross this arrow, right? So let's say you have a lower bound. So this the smallest value you get is just lower bound for your y, and this is your largest value is the upper bound for your y. So this is lower bound for y. This is upper bound for y. Okay, so apparently for different x, again for different x, you could be this lower bound upper bound will change. May not be different. It may not be the same. Because if you move over here, you got something different. If you x is here, you got different. So it really depends on actually right here. This determine my lower bound, okay, and this determine my upper bound. If you solve over here, so okay, assuming this is given by g's of x, right? For different x, it's different basically, right? So this one for different x is also different, right? So this is a h of x, okay, upper bound. So this one you have g's of x and h of x basically. Okay, now here's how you could solve the problem in a general case. I assume that everybody knows how to compute the integration. When you do the integration, here's how to do the integration. When you do the integration over here, the inner integration, for example over here, let's take a look at this. Okay, when you do the integration for this one, I take this one out. Gx hx fxy dy and dx. Now when you do the integration over here, you first do the inner integration, which is this is your inner integration. So you keep everything to be the same for the outside. You keep it over here a and b. For the inside, you consider y to be a constant. Okay, never change. It's more like a scalar, unknown scalar. Okay, so you only integrate. Oh, sorry, here, not y. I should mention here. This should be x. It should be x. This one is constant. So whatever comes here is constant. So you should consider y to be x to be constant. You only consider to be a function of y. You just integrate over y. So this integration over y by considering x be a constant. Okay. Now after doing that, you replace your lower bound, upper bound, a function of x. So here this one is a function of x basically. Now integrate, then you integrate over dx, right? So now you should get a scalar. Okay, so that's how you compute that. Okay, the last point I want to make before end of lecture is what's the typical, if I give you integrate area, let's say this is the area to integrate over, this is s. Okay, so what's the meaning of 1 dx dy? Okay, so this meaning is the same as the area of s. Okay, so similarly, if you do integration over s, any number 10 times dx dy, it's just 10 times the area of s. So the physical meaning of that is when you do this 1 of dx dy, the physical meaning is you want to figure out each small pieces. You find the area because dx dy is the area, right? You integrate that, you just you put the same weight, you just calculate the size of the area, you integrate it over all s. That's why it's just the area of s. If you do 10, just 10 times of that. Okay, you don't have to write down this one as, you don't necessarily have to do this one as the inner equation 1 dx and dy. Do you find a lower bound, upper bound? You can, of course, but you don't have to. Okay, because that's the meaning. We know the meaning, physical meaning of the integration. So when it comes back to this one, this question over here, so because this is a circle, right? So I have 1 over here. So this is actually the area of circle. The integration here is area of the circle, which is pi times radius 1 squared, right? Is pi. So you already know it. So you don't necessarily have to do this. This is, if you would have to compute this one, this is the way how we compute it, using the definition of double integration. However, the physical meaning of this one says area of the circle is just given by pi, because this in double integration means the area of the circle. Okay, so this is all I have for lectures, for the lectures for March the 23rd.